Want to make your game better. So you want to make your game better. Okay. These first 4 points are things that every game will do in one way or another, either in an over-the-top way or a subtle way, depending on what kind of game it is. And those mostly relate to game juice, or feel. The last 2 things on the list are about getting players and retaining them. So the first thing we're going to talk about is object shake. Game juice or feel is all about trying to make it so that when the player does something, they see or feel a reaction. So you'll see right here how boring it is when the player is shooting the ghost and there is some recoil and there's some knockback, but there's no shaking. So in GDevelop, it's really easy to add this. You just go to your properties manager, go down to functions and behaviors, and then search for a new extension. Search for shake, and you'll see that there's 2 there, one for camera and one for object. Both of them are very useful, but we're just going to use the object one for now. Click install, and then go to the object you want to shake, and add it as a behavior. And then go into the event sheet, and slot in the shake action, and fill out the variables. So now when I preview that, we've given a very small amount to the gun, and more to the ghost. So when you shoot the gun, it actually recoils in the character's hand, and when you hit the ghost, they wobble. But now the next thing that is kind of like shake is tweens. You've probably seen tweens everywhere. Usually you'll find them at the very beginning of the game in the start menu, when you hover over an object and it grows to show you that it's something you're supposed to press on. So in GDevelop, this is also very easy. I'll show you by putting this button into the scene, putting it onto the UI layer, and then we just go to the object and add the tween behavior. This is one of the default behaviors, so you don't need to add it as an extension. And now if I go to the event sheet, I've made these 2 events. One for if the cursor is on the menu button, and one for if it's not. If it is, we do this action, to add a object scale tween. So for this all we do is give it a name, in quotations, tell it what scale to go to, so 1.5 means it'll be 50% bigger, and then pick from a huge list of different kinds of tweens. Personally, I like to use the ease out bounce. And then we pick a duration for this tween to take. So now when I preview that, you'll see that the buttons expand when I put the cursor over them, but shrink again when I take it away. And that's because of the second event, where I changed the scale to 1:1, which is the original default scale. Tweens can be used all over the place for colors, to size, to positions, and so on. Sound effects. And I'm going to show you 3 ways to do this. Firstly, we go back to the event sheet and add an action when we hover over the button. And then we type in play and select play a sound. From here you can add your own sound effect, but we're going to create one using JFXR, which is built into GDevelop. We'll just click on the blip or select button until it gives us a sound effect that we like. When we do get one that we like, we just change the name and press save. So now when I hover over these buttons, the way to add game feel, or juice, is to make it so that when the player does something, they get a response. That could be a visual effect or a sound, or both. And the more of these you have in your game, the more fun it's going to be to play. But sound effects that get played often are going to cause a problem. So if I crank up the fire rate on this gun, you'll see what I mean. You can't really tell, but each one of those bullets is a slightly different pitch. So right now it has a randomized pitch. If I change this to 1 and it's a static pitch, it sounds like this. Which will get annoying really quick. So be sure to randomize your pitch. And then the last one is a rising pitch. So here we have a bunch of little pickups, and with a static pitch, it sounds like this. Which is fine, but if we give it a rising pitch instead, it's going to be so much better. So if we go into the event sheet, we play a sound, but the pitch is actually a variable of the player object. And so when you pick up one of these points, it plays the sound at that pitch, adds 0.05 to the pitch, and then restarts the timer. And then the timer is triggered if you haven't picked up a point within 1 second, which changes the variable back to 1 and deletes the timer. And that sounds like this, which is much better. Next are particles. And we have a video on this already, so I'm not going to explain how to do this, but I'll show you the difference. So with the particle effects, the dashing and the firing of bullets looks like this. And if we take them away, it looks like this. Which is just sad to look at. It's a good idea to add particle effects anywhere where something is coming in contact with something else, or something is being fired or clicked on or done, to give the player some feedback on what's happening. Now we get into getting players and retention. And the first one is the art. If you know how to make your own art, by all means, do it. But if you don't, then feel free to use art packs. But make sure you're using all of the art from the same one. You might get away with mixing 2 art packs together if they're similar enough, or one is for the UI and one is for the game itself. But mixing objects from different art styles all together, it's going to look ugly. So, GDevelop can help you out with this too. If you go to add a new object, you can go to the asset store, which has these amazing art packs right here for you to put into your game. And the best part is, once you find something you want to put into your game, all you have to do is click on the object, and you're brought to this screen, where you can see the animations by clicking here, and then you can click here to add the object to your game. And when you do that, you get all of the animations already pre-done for you, with names and frame rates and all that stuff done. So yeah, be sure your art packs match and make sense together. And if you are going to create new art for your game to add with your art pack, use the colors and styles found in that art pack so everything still matches at the end of the day. A good looking game with art that makes sense together is going to present itself as something more high quality, and because of that, you're just going to get more players. And now, leaderboards. Not everybody enjoys leaderboards, but for the people that do, having them in your game will double, triple, quadruple the amount of time they'll play your game. It's a really easy way to add a social aspect to an otherwise single-player game. There is no one-size-fits-all way to make a game good, but with the right amount of game feel, or juice, and the proper art, and a leaderboard, you can turn something as simple as a pachinko game into something that people will really enjoy playing. If I left anything out, be sure to comment down below so that people can see it and learn from it. I've been Helper Wesley, and I'm glad I could help. So you want to know how to get hit and then hit back. Well, the newly updated health extension is exactly what you need. You just install the extension, add it as a behavior, and you'll have access to some pretty useful tools. If you just want to use it to track health, then you just set the health in the behavior, and then you can use these 2 actions, apply damage to object and heal object, and then the condition is dead. But we're going to use the extension for more than that. We're using the current and maximum health and shield values for the UI, and we've set up this pretty dramatic hit. And if I speed this up, you'll see that when the health reaches 0, the character dies. If we go over to the event sheet, you'll see that we have this event, with the conditions if the player is in collision with the saw, if the animation isn't hit, and if the player is not dead. Then we use the action apply 10 points of damage to the player, and then set the animation to hit and play a sound effect. Then for the actual motion, we abort any current jump, so we don't have anything weird happening, and then we disable the platformer behavior, so the player can't move or jump in the middle of getting hurt, and then we add a permanent force to the player using the angle between the saw and the player. And that way, no matter where the player hits the saw, they're going to get knocked in the appropriate direction. And to get this expression, don't panic, just use the expression builder. And then next, in the event, we have a section for text object, where we create this text object at the position of the player, and then change that text object to display the amount of damage done in the above action. And then we use two tweens, one to make the text rise, and the other to fade. And when the fading is done, it will delete the object. And then lastly, we have the freeze frame. We change the timescale to 0.1, wait a fraction of a second, and then turn it back to 1, which is normal speed. And then when the hit animation finishes playing, we stop that permanent force that's applied to the object, and then we give them back their controls by reactivating the platformer behavior. And you'll see above that all of the controls and animations only work if the platformer behavior is activated. And then if we go back down, you'll see the death event. This triggers if the player is dead, and what it does is take away the platformer behavior and change the animation to dead. And then when the dead animation finishes, you delete the player. And now that we've done that, let's start playing with some of the other features of the extension. Starting with the cooldown. This is your iframes, or invincibility frames, that you get after being hit. Now to make this work, we needed to add this condition to check to see if the player was just damaged. Otherwise, everything is the way that it was. So now, and the next feature of this behavior that we're going to show is the chance to dodge. So I'll set that to 0.5, and for this I need to create a new sub-event, where if the player just dodged incoming damage, we use the same text event as before, but we'll change this to dodge. And then next I'll add the conditions, is damage cooldown active, invert it, and then once. And so now the event will trigger, and if we dodge, we do this event, and if we don't and we get hit, then we do this event. And that looks like this. And now the next feature is health regeneration. So here we have a delay for health regeneration and the rate. So when I get hit now, or now, at some point when I get hit, there we go. That's not a rounded number. To fix that, we just need to go to the event and slot in round right here. And now when I get hit, the display is increasing by integers. Now before I go to the next thing, I'm going to turn off dodge, and then go down to shield. I'm going to set the maximum to 20, and if I set a duration, then it will last to that point, and then go back to 0. But then I can add a shield regeneration, with a delay and a rate, just like before. Now if I start the game, there we go. Now if I start the game, and run into this, you'll see that the shield is going down, but the event isn't triggering. So I need to add another condition here for if the shield is damaged, and then put both of those inside of an OR condition. So if one or the other triggers, the event will happen. And then for the text display, I need to add how much damage is being done to the shield. So it's going to show me the shield and the health. And for this, it's just easier to use the expression builder. But now when we get hit, that damage event is triggering. And this extension can be used on the player or on any other object. So let's show how to give damage. If we give the behavior to the trunk enemy, and then copy down the event from the player, we can slot that into the event where the tree is in collision with the bullet object and is switching its animation to hit. And then switch out the word player for trunk in all of the events. And now, when we shoot the enemy, and they switch to that hit animation, we're taking away health until they die. And you can modify these variables on the fly with events, or you can create a bunch of different enemies with preset health, armor, dodge chance, and things like that. If you want to learn more about this extension, there's an example for it in Engine that shows all of the different components and what they can do. And if you would like to know how to set up enemy AI for your game, then check out this video. So you want to add some RNG into your game. Well, let's start with something that's easy. I've created this object and called it spawn. And if I go into the event sheet, we'll create this event where at the beginning of scene, we'll create the ghost object at the X and Y position of the spawn object. And then use the condition pick a random object, and then choose spawn. And now, at the beginning of the scene, the game will pick either the left or right spawn object, and create the ghost at the one that's picked. Now to go a little further, we can add a timer to this, and change it so that at the beginning of the scene, the timer starts, and then after 1 second, the game will pick one of the spawner objects, reset the timer, and create a ghost object at the X and Y coordinates of the spawn object that was picked. And now if I move all of these over to the side, I've got the beginnings of a wave defense game. And you can also use this same method to create a game where you avoid things. We can use the exact same setup with a timer that counts and repeats, and then a subcondition for repeat for each instance of an object, in this case being the spawn object. And then we create the asteroid at each point, give it a force downwards, and then we check each one that's in collision with a spawn point, and pick one of them at random, and then delete that one, leaving us with a random open space to try and fly through. Now if you know the X and Y coordinates of the space that you're trying to spawn enemies in, you can also do this based on those coordinates. So if I go to the event sheet and get rid of this pick condition, I can go over to the create action and change its coordinates to random in range, and use the furthest X on both ends, and the same with the Ys, to create a rectangle where enemies will spawn. But you really want to have a spawn animation if you're going to do this, because otherwise enemies will just spawn on top of the player, and it will feel really unfair. Next, we're going to take it up a notch again. We'll be spawning objects in a level using the spawn point system, but deleting the spawns afterwards. If we go to the event sheet, you'll see what I mean. So it's basically the same event, where at the beginning of scene, we pick a random box spawning object, and then create a box at the point of that object. But then we delete the object, and we have this in a repeat condition set up to repeat 3 times. And then we do the same thing for the trunk and B. And then at the bottom of this event, we pick all of all 3 objects, and then delete them to clean up all of the ones that weren't picked. And that looks like this. I can reset the scene over and over and over again, and you'll see that the enemies and boxes are all spawning in different places. And this can be used to make the same level in a game feel different. Like in Stardew Valley, where the layout of the mines are pre-built, but where the rocks and enemies spawn are randomized. And now we're going to get a little more advanced. I've set it up so that the box object breaks when you shoot it, and it's going to spawn either an apple, orange, or strawberry based on a randomizer variable that gets picked when its hit animation finishes. So just before it gets deleted, it will pick 1, 2, or 3, and then create either an apple, orange, or strawberry. And you can use this system to have randomized loot or rewards for killing enemies or breaking objects in your game. But you can use this to create bundles of different effects or things that happen based on that randomizing number. And speaking of Stardew Valley, creating a room and then randomizing where everything is inside of the room, we can do something similar in GDevelop with external layouts. Open the project manager, click to add an external layout, open that layout and link it to the scene, and then build a level inside of that layout. We can use those spawner objects again because it uses the events from the scene we're going to load it into. We go back to the main scene's event sheet, where we create an event where at the beginning of the scene, we change the scene variable to equal random in range 1 to 3, and do the same thing that we did with the randomized fruit. So if this scene variable is equal to 1, we'll use the action create objects from an external layout. Select the layout, and then set them both to 0, because our current scene is empty. And then we set it up so that if the randomizing variable is 2, it spawns room number 2, and if it's 3, it'll spawn our external layout room number 3. And this is what that looks like. Each time we reset the scene, we'll have one of those 3 external layouts get created within the scene, and then we'll be using the spawner objects to pick where things spawn within the level. Now if you want to learn how to deal damage to those enemies, watch the next video. And if you enjoyed this video, be sure to subscribe.
So you want to create randomized levels for your game. Alright, we're going to start with something simple and pick from a randomized list of layouts as we fall down, similar to the newest Shovel Knight game, Shovel Knight Dig. To begin with, I have my character in scene with an object that I'm calling bottom checker, and if I go to our external layouts, you'll see that they're pre-built layouts with a bottom checker object at the bottom. And then if I go to the event sheet, you'll see this event with the condition if the Y position of the player is greater than 200 pixels above the bottom checker object, then we change the scene variable random. Alright, we're going to start with something simple and pick from a randomized list of layouts as we fall down, similar to the newest Shovel Knight game, Shovel Knight Dig. To begin with, I have my character in scene with an object that I'm calling bottom checker, and if I go to our external layouts, you'll see that they're pre-built layouts with a bottom checker object at the bottom. And then if I go to the event sheet, you'll see this event with the condition if the Y position of the player is greater than 200 pixels above the bottom checker object, then we change the scene variable random, and then with that variable it will be 1, 2, or 3, which will create the external layout at the X and Y position of the bottom checker object, and then delete the bottom checker object that was picked, leaving only the new one from the picked layout. And then to get rid of things above the player, I've put everything inside of a group called all objects, and if those are less than the player's Y position minus 1100, delete those objects. And if I preview the game, you'll see that as I fall, the play space is being generated below me, so I could keep doing that forever. But if I go to the event sheet and change the zoom, you see that the bottom checker object is there until the player gets within range of it, and then the new layout is created, but that object is deleted. And this same setup could be used for an endless runner if you put it on its side and use the X-axis instead of the Y. And now before I get to the next method, I wanted to show you this example. It's in Engine and the link is down below. It allows you to create randomized dungeons or cave systems for your game. I'm not going to explain how it works in this video, but I've put the link to the example down in the description, and you can open it up and learn from it or use it yourself. Next is the Binding of Isaac style of generating levels, where you start with the level in the middle, and then create rooms and hallways out from that starting room. In the game scene, you'll see that we have checkers for up, down, left, and right. And then we have external layouts for a room with 4 ways, right, left, top, down, and then 4 dead ends. And if I open one up, you'll see that those also have markers based on the doors we have available. So the right-left room has a marker for right and left. And if I go to the event sheet, you'll see that we have an event for generating a room to the right. We have one for all directions, but we'll focus on this one for now. It repeats for every instance of right in the scene and picks a random right object. Then it changes a variable of that right object called randomizer and changes it to random in range 1 to 6. And then if the number of rooms is less than 8, it will use that randomizer variable to pick which layout gets created at the position of the right object. So if it's right left, it'll be a hallway, if it's right dead, it'll be a dead end, and if it's 4-way, it'll create a branching path. But if the number of rooms is 8 or above, it will just create a dead end. And then it will pick the left object closest to the right object that was originally picked and delete it. Because when we create a room to the right, it's being created off of a room that was already to the left, so we don't need that marker. And then it will delete that original right object and add 1 to the scene variable number of rooms. And that's just so that we can tell how many rooms there are so it doesn't go on forever. And we have one of these events for each checker object, and the only difference is if we create a right room, then we check for and delete the left object. And same for up, we delete down, and same for down, we delete up, because that's the direction the room is being generated in. And then finally we have these 2 events. We have all of the rooms and all of the checker objects in groups. So if a room overlaps with another room, the RNG has messed up, and we'll change the scene to the current scene to start over. And then same if a checker object is in collision with a room, that means the RNG has messed up again, and we'll change the scene to the one that we're currently in to start over. And then finally, in the case that we pick too many dead ends too quickly and we get too small of a map, where we have no more checker objects and the number of rooms is below 7, then we change the scene again back to the scene it's in to start it over again. With this setup, it's technically possible that a level will just never be generated, but it's not very likely. At 60 frames per second, this would be happening so quickly that the player really would never notice it, especially if you put up a loading screen that would hide the gameplay until it's done. Hopefully this video will help you create some levels of your own, and if you want to learn how to fill those rooms with enemies and other objects, be sure to check out this video. And don't forget to subscribe. Be sure to check out this video. And don't forget to subscribe.
With the release of Pokemon Scarlet and Violet, we thought it would be a good time to go back to when Pokemon was primarily 2D, and talk about the tools and extensions that GDevelop has that could help you make a monster tamer type game of your own, with that classic top-down movement and turn-based combat. Starting with the really basic stuff, we have a top-down character sprite with 4 directions of animations, and we're going to give that the behavior for top-down movement, and then tweak some of the values so we get the right speed and movement. And then in the event sheet, based on which direction the character is moving in, we'll change the animation to match. And then when they're not moving, we'll pause the animation and change the frame to 0, which is standing still. And then when you start moving again, we play the animation. And then for all the objects that you want to have depth, we need to go into their anchor points and drag it down to the base of the image. So for the player, it's at their feet, and for the tree, it's at the trunk. And then we go to the event sheet and use an action to change the Z order of the tree to equal the Y position of the tree. Because your Y coordinates get lower as you go up, this will change your Z order to go behind if you go above things. And then if we do the same thing for the player, you can see that once the origin point for the player goes above the origin point for the tree, the player's image goes behind the tree. But when that point is below the tree, the image is in front. Next, we'll deal with collisions. When you're working from this top-down perspective, you want the collision masks of your objects to be at the base of the image. But when it comes to games where you want the player to not be able to go through large areas, you can use an object and stretch it across the space you don't want them to go through, and then use the action separate 2 objects to keep the player from going through it. So we can expand that idea out to a whole town. But to get the camera to follow the player, we need to install an extension. If we search for new behaviors and type in smooth, we'll find the smooth camera extension. And all we need to do with that is add it as a behavior to the player object. And now the camera will follow the player around. And the next thing to tackle is dialogue. We can create a new layer, put the text object on that layer, and then, to get that classic scrolling text, we need to add the auto typing extension. And with that one, we can add it as a behavior to the text object, so we get this scrolling effect when we talk to NPCs. Next though, we're going to want some buttons. If we go to the asset store, we can scroll down and find the menu button pack, which is actually a custom object. We can click in and add one of them to the scene, and then change the animations and some of the padding, and put them in scene so we can have some ready-made buttons. And then we can use the isClicked condition to check if we've clicked on the button, and then change the scene to battle. But first, we're going to want a transition, which just happens to be something that you have access to with another extension. And for this one, we want to install the Flash and Transition extension. And for this, we'll want to make a shape painter object and give it that behavior. Then we can drag one in scene and use this action to trigger the transition before changing the scene. And now we're in the battle. And for this, we have those custom buttons, some health bars, and 2 sprite objects, one being the player and one being the enemy, and they both have the health extension applied to them as a behavior. And this behavior comes with a lot of the numbers that you want from the get-go. You've got damage reduction, starting and max health, as well as dodge chance and shields. For the health bar object, we're just taking the current divided by maximum health and timesing it by 448, which is the width of the health bar. And then for the attacks, we're using these two last extensions, the flash extension and the shake object extension. And if we go to the event sheet, you'll see that if it's your turn and the attack button is clicked, then after some tweens, we shake the enemy and make them flash, and then apply damage using the health extension. Monster Tamer games have a lot of moving parts, but hopefully you can see that these behaviors and extensions can help do a lot of the heavy lifting for you and help you get closer to the game that you want to make. And speaking of game that you might want to make, if that game includes some random level generation, check out our next video. So you want to have some melee combat in your game. Alright, we'll be doing it in this video with platformer objects, where both the player and enemies have the platformer behavior, and the ground has the platform behavior, but most of the concepts in this video should apply to your standard top-down beat-em-up as well. You would just use the top-down behavior instead. Let's go over what you need to do to create melee combat in GDevelop. First, we have a playable character with the platformer behavior and the usual set of animations. But down at the bottom, we have these two animations for thrust, and this is not an uppercut, but I'm calling it uppercut. Now if we go to the event sheet, firstly, you only have control of your character, and the animations will only play if the current animation of your character is not thrust, uppercut, or hit. Which means that while you're attacking, or being hit, you don't have control over your character. As for those controls, you have your movement controls, which will simulate the key presses for the character, and flip the character based on which ones are being pressed. And we're simulating button presses because in the behavior we have default controls turned off. And then next we have the basic animations, where if the player is moving, and they're on the floor or jumping or falling, we play the appropriate animation. Whereas if they're on the floor and they're not moving, we play the idle animation. And then we have the attacks. And for this I'm using the J key, but you can make this whatever you want. So if that key is pressed on its own, we'll play the thrust animation. But if the W key is pressed, which is up, and then the J key is pressed, instead we'll do the uppercut. And then going back to the top, you'll see that that means one of these animations is playing, so I can't control the character anymore. So then we have this event. Using an OR condition, we check to see if any of those animations were playing, and then, if that animation is finished, set the animation to idle, which means we'll have control of the character again. And then for those attacks to hit, we need something to check the collision. And in this case, we'll be creating a collision object, which is just a plain square that we're going to create at certain points on the player object. If we go to the object, and then open up points, and then go to the animation, you'll see that I have a point for thrust and uppercut, and I have them put in a place that makes sense for a particular frame of that animation. And so in these two events, we check to see if we've gone past the frame where we want to create the collision object, and then we create that at the point. And then as a subcondition, we check if that collision object is in collision with an enemy, and if it is, we set their animation to hit, and apply forces to them based on the angle between them and the player. So if they're to the right, we'll hit them to the right, and if they're to the left, we'll hit them to the left. But for the uppercut event, we also apply a force along the y-axis to knock them upwards. And then finally, we delete the collision check object. And because it's below this event, it means the object is created and destroyed before it ever renders on screen, so your player won't see it. Although, you only need to create this collision object if your character and weapon are all one sprite object. If your character and weapon are two different objects, you can actually just use the collision mask of your weapon, and then check the collision against the enemy during the right frames of the attack animation. And then to get the enemy to go back to their idle state, we have this event, where if their animation is hit, and they're on the floor, and their animation has finished playing, then you set their animation back to idle, and then stop any forces that are applied to it. Because during the collision event, we applied a permanent force to the object, so we need to use an action to stop it. And with this setup, they don't go back to idle until they land back on the ground, so you can knock them up or down, and they won't go back to moving around until these conditions are met. And then we want to set it up so the player can be hurt as well. And for this we're using a bite animation object, which is basically the same as the collision object, but this one you'll be able to see on screen. It's set up so that if the enemy's animation is idle, and they're flipped or not, cast a ray from the center of the enemy, either at 0 degrees or 180 degrees, for 40 pixels, to check to see if the player is there. And if they are, set the animation to attack. And then when the animation is set to attack, and again we're beyond the right frame of the animation, create the enemy attack object at the point that we've put on the enemy. And then check to see if the enemy is flipped, and if they are, flip the attack too so it makes sense. And then, when that attack animation finishes, change the enemy back to idle. And then when the enemy attack object's animation finishes, delete that object. And because of the way the earlier events were set up, getting hit means you won't have control of your character anymore until the animation finishes playing and the animation gets set back to idle. Now, if you would like to learn more about enemies and how to give them different behaviors and movements, be sure to check out this video. Do you like Stardew Valley? I do. So I wanted to talk about how you could achieve some of those mechanics from Stardew Valley in GDevelop, beginning with the interaction marker, which is how the game knows where to pick up an object or strike with a pickaxe, or when you can talk to a character. So I made this little target, and that's going to be our marker. In Stardew Valley, the marker sticks on a grid and stays within a certain distance from the player. For the grid, we installed the extension snap to grid, and then to make it stick by the player, we use this action, where we change the position of the object to equal the X position of the player plus this expression, which is clamp. Clamp is an expression that lets you add a min and max to your value, and in this case that's going to be the mouse's X position minus the player's X position. And we use 14 on either side because the grid is 16 by 16, and this will keep it within 9 tiles around the player. And then we do the same thing for the Y position as well. Then to make sure the marker is always below the player and objects, we set the Z order to always be 100 below the player, so there's no chance of it overlapping with something else. And then finally, with that snap to grid extension comes this action, where we snap the object to that 16 by 16 grid with an offset of 8 in the X and 8 in the Y. And that's because I've moved the object's origin to the center, which is 8 in and 8 down. And now you can see the object is following the player, and no matter where the mouse goes, it won't go further than that 9 tile distance. Next we need to animate the player. So for this top-down character, we have the up, down, left, and right, but then further down we have the same setup, but it's for an interacting animation instead. And so in the event sheet, we can see that if you're not talking to another character, and your animation is less than 4, which are the first 4 walking animations, and you release the left mouse button, we change the animation of the player to what it was before, plus 4. So if the animation was down, we add 4 to it, and now the animation is interacting down. And then we play the animation, because if you weren't moving, it was paused in the above event. And then finally, if the number of the animation of the player is above or equal to 4, which is one of the interaction animations, and the animation finishes playing, set the animation back to what it was by subtracting 4 from the current animation. So now that we have the marker to check where to hit, and an animation that plays, we can set up an event where we hit the tree. Starting with, if the marker is in collision with the tree, and if the player's animation is equal to or above 4, so they're interacting, shake the tree object, and add 1 to an object variable that we added, called hits. And then if that variable hits is equal to or above 4, and in Stardew Valley that number would change based on the tool that you're using, but for the sake of the video, I just set this to 4. So if that number is reached, we use an event to repeat 3 times, and create the wood object at the X and Y of the tree, and then delete the tree. And then to make the wood that drops out of the tree scatter and then come to you, we install the Boyd's movement extension, and then apply it as a behavior to the wood object, changing some of the values, most importantly these 3, making them 0, 0, and 2, so they'll separate when they spawn. And for this wood object we have 2 animations, one that's called spawn and one that's called pickup. So when they're first created, they have the spawn animation. And with that, using the Boyd's extension, the wood intends to move away from the player. But when that animation finishes, the animation is set to pickup, and the separation weight is set to 0 so they'll stop moving. And then when the animation is pickup, and the player is within 5 pixels, we delete the wood. And if the wood is a little bit further away, but it's below 20 pixels, we'll use this action to move the wood towards the player when they're within that distance. And this method of harvesting objects can be used for the stone, picking up crops, or chopping down trees. But that leaves us with one of the most important parts of Stardew Valley, which is the growing of crops. And in Stardew Valley, the system is pretty simple, so we'll get rid of these trees and I'll show you the plant object I have. It has a set of animations that show it growing until it becomes a flower. And then I have this tree object that has the same, just with less animations. And I've given both of them a variable I called growth, and now I'll put a bunch of these into the game. So in the event sheet, I have this event set up. In this example, I'll be using when the E key is pressed, but in Stardew Valley, this will be when you go to bed and the night ends. So if you have plants or trees planted, this is what the events would look like. So for the plant, when the day changes, we would pick all plants and change the variable growth by adding 1 to it, and then check to see if the growth variable is at a certain point, and if it is, change the animation. Because the animations of the plants don't change every night, just at different stages of growth. But the trees work differently in Stardew Valley. The trees have a 20% chance to grow every night. So we pick all tree objects and change the variable growth of those objects to random in range 0 to 4. And then if the animation is below 3, which is fully grown, and the variable growth is equal to 4, which is a 20% chance out of 5 numbers that could be picked from, change the animation of the tree by adding 1 to it, which is just a different way of doing it than how it was done for the plants. And now the plants will grow at a consistent rate, but the trees will be a little random. If you'd like to learn about some more game mechanics, like top-down movement and Z-ordering, check out our top-down RPG video. And if you want to learn about combat, we have a video for that as well. So you want to make your game nice and juicy. Game juice, or Google Trends thinks that it's called game feel, are the tiny tweaks and effects that you put into a game that makes everything just feel better. It's the sort of thing that makes hits feel satisfying in One Finger Death Punch, or shooting in Nuclear Throne. It's the sort of thing that takes an okay game and turns it into a great one. And so we're going to be going over this example, created by Sleeper Games, that's actually already in engine and you can see it for yourself. It breaks down the different parts of game feel that relate to combat or firing a gun. And we're going to start with hit lag, otherwise known as freeze frame, where something strikes something else, and on the moment of impact you freeze the game for a frame to give you a moment to appreciate the impact before going back to the regular speed of the game. So the easiest way to do this in GDevelop is by going to the event where the collision happens, changing the timescale to 0 or close to 0, waiting for a fraction of a second, and then changing the timescale back to normal. Personally, I think this works best for melee games, or to emphasize when you as the player get hit. Next is visual effects. Usually particles or a sprite that's drawn to show sparks or splatter or gusts of wind, and things like that that help you sell impact. It is definitely possible to go overboard with particles, but having them in just the right place will definitely help sell the effect. We already have a video on particles, so we'll move on to the next point. Next is hit flash, which can be a tinting of the character or a flashing of their visibility. Usually a tinting of the character is used on enemies, and for the player, it's the flashing of visibility, because the player will definitely want to know where the enemy is on screen at all times. And to tint the color of a character, there is a tint action, but the easiest way to do it is with the flash extension, where you just install the extension, and then add it as a behavior, and then set the duration of the flash in the action when you trigger it. Next up is wobble, also known as squash, stretch, and shaking. The easiest way to achieve this is with the object shake extension, where you install the extension and then apply it as a behavior to the object that you want to shake. And then when you trigger that shake, you determine how you want it to look. If you can't get the exact look you want with the Object Shake extension, you can use tweens, and for that one, we've made another video. And then the second last one is damage text, which isn't going to apply to all games, but any game where the damage that you do varies based on how strong you are or your enemy is, you will probably want damage text. So the easiest way to create damage text is just to make the object, and then at the point of collision, use the action create an object, then modify that text object to show the variable you want it to, and then tween its Y position upwards, and then toggle the setting to delete the object when the tween is finished. Different games will have their text tween differently, but that's just a matter of setting up different tweens to match the style of your game. And then the last one is screen shake, which is massively important. Screen shake gets used all over your game, like at points of collision, or when heavy doors open. And this is probably the easiest one to use of all, because you just install the extension, and then go to the point where you want it to trigger, and use the action to shake screen, and then set the duration to be what you want it to be. These techniques are used in basically every modern game. Some games use them more subtly, and others go over the top. And now to learn how to use particles or tweens, check out these videos. Have you ever wanted to make a 3D game using GDevelop's no-code system? Well, now you technically can. All of this is happening inside of GDevelop. This game was put together by Entropy using an extension created by Pandaco that allows you to use 2D textures as walls, floors, and ceilings, and as these 2D projected sprites that look at you the same way regardless of how you're looking at them. And I've seen Pandaco make a couple of games with 3D models, but I honestly have no idea how they're doing that. But let's pick this apart. If I take off the ceiling, you'll see what this room looks like in the editor. It's just a bunch of 2D sprites laid into the room, and I can move them around and manipulate them just like I would anything else. But then when the game starts, they're projected in 3D, and I can shoot them and interact with them. And these tiled sprite objects make up the walls, and if I move it around and start the game, you'll see what's happening. It's basically a tiled sprite stretched across a 3D box. And this all amazingly works with behaviors. These 4 different behaviors are what turn normal sprites into 3D sprites. So if you don't give the objects any of these behaviors, they'll just show up on screen like 2D sprites, and then you can use those for the UI. And of course, the first thing that I tried to do was create a horror game. Where I found that a couple of vignettes really changed the atmosphere of the game. Also, that you can work on different elevations, and you can use an offset on a tiled sprite to make running water or a parallaxing background. In the description, I've linked to Pandaco's YouTube channel, where they're showing off some of the things that they're doing with the extension. Like how they've created a proper racing game with some basic 3D models. And what's really cool is that on their itch.io page, Pandaco actually has some examples that you can download and play with yourself, so be sure to go check that out. Be warned, this extension is still in development, so if you want to try this out, understand that you'll be walking into a new frontier. GDevelop is first and foremost a 2D engine, but this is really cool. And speaking of 2D games, we have videos on how to make a game like Stardew Valley or Pokemon, so give those a watch. Let's talk about Cookie Clicker, a game that was originally made in 2013, but is somehow still one of the most played idle games in the world. So let me show you how easy it is to make this game in GDevelop. To begin with, I have 4 objects. A text object to show you how many cookies you have, the cookie image, a custom button object behind it, and another custom button object to use for the upgrades. You get the custom button object by going to the asset store and finding the menu buttons pack. Pick one of the buttons and add it to your scene, and then change out the images to be whatever you want them to be. And then we have 4 scene variables. Cookies, of course, which is a number variable set to 0, and then we have this one called upgrade 1, set to a structure, and we gave it 3 child variables: cost, number bot, and timer. Because basically all of the upgrades that you buy in Cookie Clicker work off of these 3 variables. You need to know how much it costs, how many you've bought, and what time to trigger them. Most Clicker games will have other mechanics built on top of that, but at their core, that's how most of them work. When you buy an upgrade, you subtract the cost from how much you have in the bank, and then use the total number you've bought to adjust the timer, to increase how much you get per second. So let's look at the events. The first event is to hide the big button at the beginning of scene, and then the next one is just for that fancy scrolling background. Then we have the clicking event, where if the button is clicked, we'll shake the object using the shake object extension, and then change that cookie variable by adding 1 to it. And then to display the variable, we modify the text of the text object and set it to the text of the scene variable called cookies, plus, in quotations, the word cookies. And that way you'll get the number and the word. And now we'll open the group for upgrade 1. And you'll see that if we click on the upgrade and the cookie variable is greater than or equal to the cost, then we'll trigger the actions to subtract that cost value from the cookie total. So we've spent cookies to get the upgrade. And then we change the number bot value of that upgrade by adding 1 to it. And then for the timer, we'll change that variable by setting it to 1 for 1 second, divided by the number we've bought. So if we only buy 1, the timer will be 1 second. And if we buy 2, it'll be 0.5 seconds. And if we buy 3, it'll be 0.333333333 seconds, and so on. And then we change the upgrade cost, because in all of these games, each time you buy an upgrade, it increases the cost for the next time you do it. So we change the variable cost by setting it to what the upgrade variable currently is times 1.2. So we increase it by 20%. And then you'll want to use the round expression to make it a nice whole number. And then this is for the label of the button. So looking at the button, all we want to change is the cost and the total cookies per second. So we have idle upgrade number 1 and cost, in quotations, plus the text of the cost variable, plus, again in quotations, cookies per second, plus 0.1, and total cookies per second, plus again, the text value of the number bot, times 0.1, because for this upgrade, every additional upgrade gives you 0.1 cookies per second. And then I'm using round 2, the second decimal point, so that it's displayed as a rounded number. And then finally, to earn those cookies on a timer, we need these 2 events. The first one being that if the number bot is greater than 0, start the timer called upgrade 1. And then the next one is that if the timer, upgrade 1, is greater than the timer variable that we changed earlier, then we add 0.1 to the cookie total and then reset the timer so it starts over. And this is what that all looks like. I can click on the cookies to give me 1 cookie per click, and then once I can afford the upgrade, I can buy it, and then I'll start earning 1 cookie every 10 seconds. And if I keep doing that, it will increase the cost and the total cookies per second. And that's the basic way these games work. So once you've got 1 upgrade set up, you can duplicate your button, add it into the scene, and then copy and paste your upgrade variable and change it to 2, so you'll have 2 sets of variables, and then copy and paste your event group, and change all of the 1s to 2s to get a second set of upgrades. And then you can keep repeating that until you have enough upgrades to fill an entire game. So those are the basics for how passive upgrades work in clicker games. But a lot of clicker games rely heavily on game juice, because you really need the button to be a fun thing to press. So if you want to learn about game juice or game feel, check out this video. So Metroidvanias are all about locks and keys. Whether it be a new mechanic, a weapon, or a literal key, that's one of the key parts of a Metroidvania. So to show how that works, I created this level that has some obstacles that you can't get through without first picking up the required item to do it. So for this example, I have a platformer character, and I've installed the extension Advanced Jump. That extension gives you a bunch of different behaviors that you can add to your platformer character to give them different movement mechanics. And I've given them all to the character, but we're going to focus on double jumps, dashing, and diving. So we'll go to the event sheet, and you'll see that the first obstacle requires a second jump. So when the player is in collision with the jump object, delete that object, and change the number of times the player can jump in midair by using the expression for player jumps, which you just find with the expression builder, and then +1. So because I could jump once before, now I can jump twice. And then you can do it again or however many times you want to, and give your character a double, triple, or quadruple jump. But then we run into an obstacle that we can't get over. So instead we're going to try to break through the wooden blocks below them. And for that, in this example, when the player runs into the dive object, delete the dive object, and set the Boolean value of the scene variable for diving to true. If I go to the scene variables, you can see what's happening here. I have a Boolean scene variable set up for both the dash ability and the dive ability, and I've set them both to false. So when you run into that object, it sets that Boolean to true. And then up here in the controls, for diving, we have it set up so that when we press the shift key and the Boolean variable is true, then we're able to make the player dive, as long as the S key is pressed to go down and the player is not on the floor. And then back down here with the upgrades, I have it set up so that when the player is diving, we cast a ray from the player object down 20 pixels to check for the wood platform object. And if it's there while you're diving, it shakes the object and starts an opacity tween, which if we open it up you can see is set to delete the object once it's done. And then you can fall and move on to the next one. And then this last object is for the dash. When we collide with it, we delete it and set the dash variable to true. Which again in the controls is set up so that when we press the shift key while pressing either A or D, and that dash variable is set to true, then we can dash. But then next are doors to get through, which is one way to do the lock and key mechanic for a Metroidvania. If we open up the scene variables again, you'll see that I have one set for fire and key to get us through the key block and the ice block. So just like before, players in collision with object, delete the object, set the Boolean variable key to true, so the game knows you have the key, and then we'll use this condition to check if a point is inside of the key block. And this point is one that I set up in the player object. So we check if the point is in collision with the lock block, and if the Boolean variable is true, then we change its opacity to 100 so we can see through it, and deactivate its platform behavior, so it's no longer an obstacle for the platformer character. Next, under this wood platform, we have a fire object, which is obviously used to melt the ice block. So again, collision with object, delete object, set the Boolean variable fire to true. Then we check to see if that point is inside the ice block, and if the tween melt exists, because that's the one that's being used in the tween to get rid of the door. And then check if the Boolean variable is true to activate the tween, which will change the height of the ice block to 0, so it looks like it's melting. I will suggest that if you're making something as big as a Metroidvania in GDevelop, that you use a tile map object, because it's much better for performance, and once you get it going, it's easier to set up. Now, a lot of Metroidvanias have melee combat, so if you'd like to learn something about that, check out this video. So you want to make a roguelike. Roguelike was a term that originally meant a game like Rogue, which is an older game that doesn't look like most modern roguelikes. The meaning of the word has adjusted over time to focus on two core traits that Rogue had, which was permadeath, which is really easy to do because you just delete the save file when you die, or don't save in the first place, and randomized levels, which is the tricky part because that includes enemies, upgrades, combat, and the rest of the game itself. We've covered different aspects of a roguelike game in different videos, so I'm going to put those tutorial videos into a playlist and stick that at the end. But for this video, we're going to be taking apart a game that I, the person behind this voice, have been working on in my spare time. It's probably best described as an action roguelike, but it should still be an interesting example. A quick disclaimer, this game is still a work in progress, so it might not look great, and it might not be perfectly optimized, but I'm mostly going to go over concepts rather than going deep into the events. So let's just start with the character. This game has 4 different characters, and all of them are inside the same object. They're just different animations. So in the overworld, when you pick a character, it will change a global variable from 0 to 3, based on which character you picked. And then in-game, the animations for the character, which in this case are just idle and walk, are picked by the number that correlates to the animation number. So for the idle animation, it's just that variable times by 2, because there's 2 animations per character, and then for walking, we add 1 to pick the walking animation. If you have characters that have vastly different movement styles and mechanics, you might want to use different objects, but in my game it's mostly cosmetic, so having all of the characters in one object is simpler. And then for shooting, I'm using the fire bullet extension, which you can install, put on the character object, and then in-game, use the action fire bullet when the left mouse button is pressed. And you don't need to worry about the rest of these actions, because those are just effects, like creating the dust particles, shaking the gun, playing a sound, and the recoil on the gun. For the enemy AI, their controls are based on their animations. So when the ghost is in idle, it'll move towards the character. But once the ghost gets within a certain range, it'll change to charging, and then when that animation finishes, it'll fire a bullet, using the fire bullet extension, change to its resting animation, and then after its resting animation, it will change back to idle. But if the player is still in range, it will go straight back to charging, to shoot again. And if you shoot the ghost enemy, regardless of where it is in its animation, it will switch over to hurt. Some enemies will have some other specific mechanics, but for all of them, the animation that's playing controls what they do and when they do it. Now for the room generation, in my game there is no permanent dungeon being generated. We do have a video though, and it will be at the playlist at the end. But in my game, every time you move to a new room, it creates a new room and deletes the old one. And if I pull out these layers, you can see what each room is made of. Each room consists of a trap, doors, a floor, walls, its own unique vignette, and room vegetation, which I'm using to randomize how each room looks. So when you move over to a new room, we pick an animation for the room floor based on the door we came through, and then pick the walls and doors based on that, but then the vignette, traps, and room vegetation are all picked randomly. So each time you walk into a new room, it will look different, but also the enemies that will spawn are different. So let's talk about the enemy spawning and the damage level. So each time you walk into a new room, the damage level goes up by 0.2. And what I have set up is a scaling list of enemy spawns based on that damage level. So the further into the game you get, more enemies will spawn in each room, and more difficult ones will spawn. So you can see that if the damage level is less than 3, but above 1, it will pick enemies using this scene variable that's picked above. In the first room we go into, we're going to get 2 ghosts, and, based on that number, another ghost, a spider, a slime, 2 bees, or another ghost. And then as you go further down the list, you get more enemies per room, and you start seeing new enemies that you didn't before. And then for scaling their health, all of the enemies are using the health extension. So repeating for every instance of an enemy, we set the health of the enemy group, which is a group that has all of the enemies in it, to the health of the enemy group times the damage level divided by 2. So every time the damage level goes up a whole number, it's a new number being timesed against their health, so they show up with more health as you get further into the game, which makes the next part really important. If we go over to the scene variables, you'll see that I have character stats: accuracy, defense, fire rate, health, power, and so on. And those are used to tweak the gameplay. So for example, when a bullet hits an enemy, it reduces that enemy's health using the scene variable for power. And those stats are changed using upgrades, which in my game are set up as animations. So once you've gone a certain distance into the damage level, these coins will pop up. And when they pop up, we change their animation to an integer between 0 and however many upgrades I have. And then when I click on a coin, it will adjust those scene variables to make me harder, faster, stronger, whatever, so I can survive longer in the game. And those are the basics of how the game works. The base version of this game, with 3 enemies, 1 character, and 1 gun, is entirely free for you to use in the engine. So you can open it up and learn from it, or open it up and build off of it to make your own game. There's a link to that in the description, but as for that playlist I mentioned, with videos that are relevant to roguelikes, that playlist is right here.